Hi guys, welcome back to my channel. Today we're going to be looking at tree diagrams and two-way tables to determine probability of different events. We've looked at tree diagrams and two-way tables previously, so this should just be a revision of some content that we've already done before. So let's start off with a very simple example. We've got a coin and we throw the coin twice. What's the probability of getting two heads? So here's something that we need to consider with this event, and that is that coin tosses are independent. And if I toss a head on the first go, that's not going to influence whether I get a head or a tail on the second go. So when we have events that are independent and we want to find the probability of getting a head and a head, we're going to multiply the individual probabilities. So here we can see I've got a very simple two-way table, a tree diagram which models this exact scenario. And if we have a look just here, we can see that we've got the four potential different outcomes. Out of our four outcomes, only one of them is going to be two heads. So straight away we can already see just from this diagram that the probability of getting a head and a head is going to be equal to 1 out of 4 or 0.25. Let's have a look at this using our multiplication rule for AND statements. So the probability of getting a head and a head, given the fact that this is independent, is going to be found by multiplying the probability of a head by the probability of getting a head. So this is going to be 0.5 times 0.5, which is equal to 0.25. If we wanted to, we could model this situation in a slightly different way by using a two-way table, and we should still get the same information. So this is the exact same scenario now, except using the two-way table. And again, we can see that the probability of getting two heads is going to be 1 out of 4. Let's have a look at calculating probability of dependent events. So an event is dependent when the outcome of the previous event changes the probability of the next event. So we've got an example here. You're off to soccer and love being the goalkeeper, but that depends on who's the coach today. With Coach Sam, the probability of you being goalkeeper is 0.5 or 50%. With Coach Alex, the probability is only 0.3 or 30%. Sam is coach more often, about 6 out of every 10 games. So what's the probability that you will be a goalkeeper today? Let's set this up and let's start by doing our tree diagram. So the first event is choosing which coach is going to be there today. So we know that Sam has a 0.6% chance of being the goalkeeper today. So that means that Alex must only have a 0.4 chance. Now, if Sam is the coach, there's a 50% chance that you will be the goalkeeper and a 50% chance or a 0.5 chance that you won't. With Alex, it's much less likely. It's only a 30% chance that you'll be the goalkeeper, and it's a 70% chance that you won't. So how do we find this probability? Well, what we're looking at is we're looking at all of the options where the outcome is yes, you get to be the goalkeeper. So let's find this and let's use our multiplication formula. Now, the only difference between the two formulas is still doing multiplication. When they're independent, you just multiply the individual probabilities. Now what we're going to do, we're going to write the probability of getting goalkeeper. Okay, that's going to be equal to the probability of Sam being the coach and getting a yes, plus the probability of Alex being the coach and getting a yes. Okay, so let's break this down. So the probability of Sam being the coach and getting a yes is equal to the probability of Sam multiplied by the probability of yes, given that Sam is the coach. So the only difference here between the last one, remember with the last one we wrote the probability of the head times the probability of the head, is the use of this given that symbol, and that's the only difference. So we're going to use our tree diagram to help us now. So following this pathway here, the probability of getting Sam is 0.6, and the probability of getting a yes, given that you have Sam as your coach, is going to be 0.5. So therefore there is a 0.3 or 30% chance of you being the goalkeeper with Sam. Now let's find the probability of you being the goalkeeper with Alex. So same thing, we've got the probability of Alex and a yes, and that's going to be equal to the probability of getting Alex multiplied by the probability of getting a yes, given that you have Alex. And again, we're just going to follow this pathway here. So 0.4 chance of getting Alex multiplied by 0.3 chance of getting yes is 0.12. So if we have a 0.3 chance with Sam and a 0.12 chance with Alex, adding those together, this is going to give us a total of 0.42, or a 42% chance that you're going to play the goalkeeper today. Honestly, I don't think that's too bad. That's pretty good odds. Let's have a look at this example again, and we're going to do this using a two-way table. What we saw in the previous example is that if this was heads and tails, we would write 0.5, 0.5, because they're both equal chances of occurring. But as you can see, that's not quite the case here, because if you have Sam, the chances of yes are different than if you have Alex. So it's just something to keep in mind, but it's not going to change what you need to do. You just need to multiply those probabilities along each of those branches, or along each of these tables. So that's how we use tree diagrams and two-way tables to calculate probabilities of different events. All right, guys, I'll see you in the next one.